A big three-phase motor cannot just start straight across the line. Hit it with full voltage from a dead stop, and the inrush current jumps to 6 or 7 times its running current. That spike dips the supply, nuisance trips the breaker, and slams the whole driveline. So how do you start a large motor gently, with cheap, simple gear? The classic answer is the stardelta starter. In this video, I will show you exactly how it works. The 3 contactors, the timer, the 1 interlock you must never get wrong, and then the same logic as a PLC ladder program. Let's start with why. Quick note before we dig in. This is from PLC Simulator, where you can build and run motor control and ladder logic free, right in your browser. No install, no hardware, no panel to wire. The link is in the description. Click the link in the description to try it free. Now, back to the starter. Here is the core trick. A stardelta starter changes how the motor windings are connected during the start. First, it connects them in star, also called Y. In star, each winding does not see full line voltage. It sees the line voltage divided by the square root of 3. That is about 58%. Less voltage on each winding means far less current. It cuts both the starting current and the starting torque to roughly 1/3 of a direct, full voltage start. So the motor pulls away softly. It spins up without that violent inrush. Then, once it is near full speed, the starter switches the windings into delta. In delta, each winding finally sees full line voltage, and the motor delivers its full running torque. Reduced voltage start, full voltage run. That is the whole idea. To pull that off, a stardelta starter uses 3 contactors. Say their names with me, because the sequence depends on them. First, the main contactor. It feeds line power to one end of the motor windings. Second, the star contactor. It ties the other ends of the windings together to form the star point. Close it, and the motor is in star. Third, the delta contactor. It reconnects those winding ends so the motor runs in delta. And tying it all together, a timer. The timer decides how long the motor stays in star before it flips over to delta. That is it. Main, star, delta, and 1 timer. For parts that do the whole job. Now watch the sequence. This is the part people get wrong. On start, 2 contactors energize together, the main and the star. The motor begins turning in star at reduced voltage. At the same instant, the timer starts running. The motor accelerates while that timer counts down. When the timer times out, the changeover happens. First, the star contactor drops out. Then, after a tiny dead time gap, the delta contactor pulls in. Now the motor is in delta, at full voltage, running normally. So the order is simple. main+star start. Timer. Drop star. Close delta. The main contactor stays in the whole time. And here's the one rule you absolutely cannot break. The star and the delta contactor must never be closed at the same time. Ever. If both close together, you bolt a direct phase-to-phase short straight across the windings. That is a dead short on the supply. Flashover, trip protection, possibly a wreck starter. So every stardelta control circuit carries a hard interlock. You wire each contactor's normally closed auxiliary contact in series with the other one's coil. Star is in, its closed contact opens so delta physically cannot energize. And the other way around. The interlock is not optional. It is what keeps the starter from destroying itself. Now the PLC version. The good news, the exact same logic drops straight into ladder. A start button latches a run bit, and that run bit energizes main and star. The same run bit starts an on-delay timer, a TON. While the timer runs, the motor sits in star. When the timer reaches its preset, its done bit flips. That done bit drops the star coil and picks up the delta coil. And here is the key. The star and delta coils are interlocked by each other's normally closed contacts, exactly like the wiring, so they can never be energized together. Here is that wrong. Watch the most common mistakes too. No interlock between star and delta. A transition time set too short, so the motor is still drawing heavy current when delta slams in. And forgetting the dead time gap between dropping star and closing delta.
I cover the start-stop seal-in and the VFD versus soft starter trade-off in the linked videos. So here's what to walk away with. A stardelta starter starts a big motor in star at reduced voltage, then switches to delta for the full voltage run. 3 contactors, main, star, delta, and a timer drive the changeover. And star and delta are always interlocked, so they can never close together. Get the timer and the interlock right, and it is rock solid. Now, go make it concrete. If you want to build motor control and ladder logic hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.